with it not being that great of a user experience in the first place. So phishing and malware typically bypass these pretty easily when they try. So why biometrics, right? Well, the answer is biometrics are here today, now, and they're happening. And they're happening for several reasons. First of all, the core companies that make computer chips, Intel, Qualcomm, ARM, they're making biometric readers now. And they're making their computer chips compatible with different biometric readers, which is something that's never really been done before. And device manufacturers like Samsung, they're building biometric devices. A lot of people in here probably have an iPhone with a fingerprint reader. These are becoming popular. And finally, operating systems, Windows 10, iOS, Android M, are all coming out with biometrics and biometric support. So it's happening. And it's said that before the end of next year, 1 billion people on the planet will have some type of biometric reader either on their desktop or in their pocket, which is pretty cool. So why not take advantage of it to do authentication, right? So before we can use biometrics for authentication, how do you do something like that? What are the rules, right? Biometrics isn't something that's totally new. It's been around for a while, but now it's actually economically and technologically feasible on a mass scale. So the first thing we have to do when we think about using biometrics for authentication is it has to be secure, right? Somebody can't say they are. Somebody can't say that they're me, basically. And they can't access my accounts unless they're me. So second, it has to be simple and convenient. Passwords aren't really that convenient, especially when you're forced to have like a 16-digit password or a 16-character password, and you have to type it in everywhere. And it's 10 times worse when you have to do it on your phone where the screen is small. So it has to be convenient. And two-factor things like you might have used the SMS messages, Google Authenticator, or if your company uses RSA tokens, it's anything but convenient, right? So it has to be simple. Non-technical people have to be able to use it easily, which is the biggest thing. Third, it has to be interoperable. It needs to be able to work on any system. So you need to be able to log into your phone, into your desktop, into your iPad at home, whatever. It needs to just work without you having to jump through a bunch of hoops. And this kind of ties back into the whole simplicity thing too. So one of the more important things is it has to ensure privacy, right? My biometric data, my fingerprints, they have to be kept safe. And I shouldn't be able to authenticate to anything without knowing for sure that I'm not risking my privacy. So one of the huge things about biometrics and kind of why it's been a touchy subject in the past is this concept of it being revocable, right? I can change my password whenever I feel like it. I can change it right now for every single one of my accounts. It's not a big deal. But I can't change my fingerprint. I can't change my face that easily. And I can't change my retina, right, for example. So how do you ensure that you can revoke access to things without compromising the user's privacy and losing their biometrics and all that stuff? And how do you do that securely? So let's look at how biometrics is used. Here we'll look at an example of how you would use biometrics to authenticate to something, and then we'll talk about how these rules are actually enforced in that process. So let's say you have a user who wants to log into some machine or some app or some phone, right? They go to log in. The way that works is a challenge token gets sent to the biometric on their iPhone, for example, or their Samsung S5 that has a fingerprint reader. And this challenge token is just a random number or a random string. Once it gets to your biometric, you have to verify your biometric, right? So this is typically a fingerprint or a face recognition camera or whatever it may be. Once you verify your biometric, you actually sign that challenge token with a private key. You cryptographically sign it. Now, once that signature is done, that signature is then forwarded to a server-side component, and that server-side component uses the corresponding public key to verify that signature. So the point here is the only way that you can initiate this signature here is if you biometrically prove that you are who you say you are. So once the signature is verified on the server side, we know it's you, and we give you access to the account. So it's really simple. So let's think about how this applies to the 5 rules we talked about. Is it secure? Well, we use the user's biometric authenticator, which is their phone, for example, here, to verify their identity. This verification occurs outside of the operating system. It occurs on a separate device, on a separate chip from the main operating system. So this is what those chip manufacturers like ARM and Qualcomm are doing. They're actually separating this point of authentication from the main operating system. So even if you have malware running on your OS, you don't necessarily lose your fingerprint data. It can't spoof that. It's simple and convenient, right? The user no longer has to worry about choosing a secure password if they're authenticating this way. Your company doesn't have to worry about making sure that their password is strong enough, that they're changing it every 90 days, other things like that. They simply just tap their finger on their device or use the camera to authenticate. It's interoperable, right? So you can use any biometric that you have available to you. So whether it's in your pocket or on your desktop, you can use it to log into things. And these are becoming more and more available as time goes. It's privacy enhancing. So from this perspective, your biometric data never actually leaves that secure zone on your phone. So it's not stored in a centralized repository, right? In the past, the way you do biometrics is you store everybody's fingerprint data in a database, and then when they scan their finger, you compare it to that database. And that's no longer the case, right? Because when you're storing people's information in a centralized place, that suddenly becomes a really, really juicy target for a lot of hackers, especially when you consider the fact that biometrics can't be revoked or changed. So when you decentralize the storage of biometric data, suddenly a hacker has to go from phone to phone to phone to computer individually and hack those. And that no longer becomes economically feasible for them. So that's the point of that. And it's revocable. So if you look at the server side here, how we verify the user's identity, we're doing a signature verification with a public key. So if that user's device gets compromised or stolen or something, you just revoke that public key. And you never have to worry about them logging into that system again, which is great. So this is how that works. Now I'm actually going to talk about what we do and what is Hypr. So what we do is we build an ecosystem and we build a platform that allows you to do all this stuff. So on the client side, I'm talking about phones, laptops, desktops, etc. We build client-side software that allows you to interface with the biometric that's on that device. On the server side, we deploy a server that does the verification of identities. And this can be either SaaS-based or on-premise, depending on the organization. And finally, there are some places, primarily government installations and big-time enterprises, where they would never trust a consumer device to do authentication, even if it has biometrics. And for this scenario, we created a biometric authenticator that's based on fingerprints to do just that. So it's FIPS compliant. It's got Bluetooth, so it can connect to any device or whatever, and you can use it in lieu of a biometric. So that's actually what I'm going to demo today. So I'm going to demo a real quick example of me logging into my American Express account using biometrics, right? So.
I'll do that for you.
There really isn't. I have my biometric authenticator here. So this is the token that I just mentioned that we make. It's Bluetooth. And so clearly my laptop here, which is a MacBook, it doesn't have a biometric on it. Right? It doesn't have a specialized camera that reads my face. It doesn't have a fingerprint reader or anything. So I have my biometric authenticator here. It's got a fingerprint reader on it. And now I'm going to go to my American Express account. I'm going to refresh this page. When I hit the login page, instead of putting in my username and password, I see this pop up that says log in with your biometric. And the reason I see that is because I'm connected to my laptop with this token. And so I have a button here that says use your Hypr token to log in. So I click that button, I swipe, and I'm logged in.
Yeah, buddy.
Right? So this all happens on the back end. I don't have to worry about memorizing a long password. I don't have to worry about any of that stuff. Swipe my fingerprint and it just works. So it's the simplest demo you could possibly ever do. Yeah, which is actually, I'm surprised that it did work. Like I was expecting something bad to happen because that's what happens every time. But yeah, so, you know, that's the demo. Obviously I'm using this because my laptop doesn't have a biometric. But if I had an iPhone, I could use that. Or if I had a Samsung S5 with a fingerprint reader, I could use that. Over 1 billion people are going to have a biometric before the end of next year, so they'll be able to use it.
Does it support other browsers of Chrome?
Yes. So basically, we give you the client-side code that you can implement in any browser and any operating system. So we build client-side code for Chrome, Firefox, Safari, not really Internet Explorer, but it's dying off anyway. So, but we have clients for Windows as well as OS X, and we're building Unix or Linux, different distributions, and we also have Android and iOS as well. So, any other questions?
Where's the private key stored on your MacBook?
It's on here. It's on my token. So when I swipe my finger on this, the token verifies my fingerprint, and then it cryptographically signs the challenge that was sent to it from my, yes?
So if you use another device, you have to authorize that device before you now authenticate using that.
Precisely, yeah. So when you first get a biometric device, you authorize it for that particular product, and then from then on you use that. And then if you lose it, you basically, the public key gets revoked, and then you, when you get another device, you have to authorize that device.
Can you have more than one device authorized?
Yes, absolutely. So it's all tied to a device and a particular private key pair.
Okay.
Yes, sir.
Okay. Do you have anything for under duress? Do you know what I mean?
Not necessarily.
Under duress, someone swears you to swipe your thumb, or somebody takes your thumb, and then you authorize.
So that's a good question, and that's kind of an edge scenario, right? But but yeah, no, it's a good question. That basically, so let's take the example of my finger got chopped off, and somebody's going to use this thing, right? Because that happens, and then. So basically, the fingerprint reader that we use on our particular token, for example, does like static checks on your finger and all this stuff. It has, so it can't be fooled that easily, but it's still, I'm not going to say it's impossible. But the idea is in order to gain access to people's accounts, you have to chop all their fingers off or force them to. So, and you have to do it one by one.
So the demo that was shown at CCC 2 years ago against the Apple iPhone, where I could with some Scotch tape make a simulacrum of your fingerprint.
Yeah.
That's an area sensor, so
Okay.
it's actually verifying an image. This is a swipe sensor, so what it's doing is it's actually reading the 3D ridges of your thumb.
So a clay copy of your thumb.
Yeah, exactly.
Okay.
So yeah, the point is you have to make it difficult enough for hackers, right? So you have to go and hack individual people's phones or individual people's fingerprints or their individual biometrics to hack into their account instead of having this centralized place where you can get into a server and crack the password hashes and just have access to everything. Yeah, I saw a hack a few years ago. It was at a big bank, right? This guy in India, he was like super rich. And these guys figured out his username and password to his bank account by phishing him. And they figured it out. And they tried to log into his bank account, but they didn't have the SMS message, right, that gets sent to his phone to type in. So these guys were really smart. They created a fake ID with the guy's name, and they walked into Verizon. And they said, I lost my phone. And they gave him a new phone. And before the guy realized that his phone wasn't working, they had access to his bank account and cleared it out. So these things are possible for sure, right? But you have to make it that difficult. I mean, think of all the work these guys had to go through to do that. In that particular instance, it might have been worth it. But in most cases, it's not. Yep.
So that's where I'm sort of curious, because if you're securing information with this sort of thing, then I'm thinking Department of Defense, military, things like that, where it is worth it to sort of go that extra mile. So I think your ultimate adversary is sort of people willing to walk into the Verizon store and fake the identification.
Yeah, so in terms of our product, like our point is to make it secure and really simple. Like anybody can do this, right? So if you're talking about like DoD, like mission critical stuff, you know what, you don't have to worry as much about convenience. You can say, you know what, you have to use the biometric and a 16-character password and a separate hardware token that does two-factor or something. You can do that, and there's nothing stopping you from doing that. Yes?
Can you talk a little bit about the actual, it sounds to me like you're actually the technical fingerprint of the device itself. Right? On the challenge, are you doing the technical verification of the device itself, device fingerprinting?
Yes, so
How does that work?
when the cryptographic signature happens on this token itself, it's not just the signature of the challenge by itself. There's also a bunch of other metadata that's associated with this particular piece of hardware that's unique to it.
So you're doing browser information along with the
So,
chip itself?
MAC address.
You're hashing it?
Yep, and so the information of this particular token, information of this laptop, information of the browser, it all gets verified.
So you're matching the device fingerprint with the biometric fingerprint for basically two-factor.
Yeah. So if you want to think about it that way.
I think that's a good way to think about it.
Yeah.
Really achieving two-factor. You need
Yeah.
to have that device.
But typically nowadays when you think about two-factor, you think about like,
Something you have and something you are.
yeah, well, something you have and something you know in the typical sense, like right now.
So that's one of the other factors,
Mhm.
and then somewhere you are the fourth factor.
Yeah,
So you're essentially achieving two factors with the device fingerprint.
yeah. But we don't tell people that. We're a biometric security company, right?
I did. You really are a two-factor authenticated. Realistically, you're achieving two-factor authentication.
Yeah.
Well, you also need to have a device that's been authenticated,
Mm-hmm.
and then you need to have a fingerprint, the biometrics. that's
Yes.
authenticated.
Yes, but if we also mandate a PIN on the client layer, then it's a third factor. It's up to the
It's something you know,
developer.
right? So, but you're not, in your business model, I can't tell if you require.
No, it's completely optional to the company that deploys it. But just from a usability perspective, for us, it's infinitely more secure than just a password regardless. So why not make it user-friendly too?
But people share hardware tokens. I can't share this with you because you don't have my phone.
Yeah, right, so that makes it two-factor.
Correct.
Okay, so you
Yep.
authenticate the token and then the person.
Are you saying that there is an option, though, to add a third factor?
Oh, yeah. Yeah, absolutely.
Because that's the easy part, right?
Yeah, that's what you're already doing, right? So,
Sure.
The easy thing would be to throw GeoIP in for somewhere you want.
yeah.
The device, though, holds your private key.
Mm-hmm.
I assume there's some kind of defenses for me popping it open and JPEGing it out?
Totally. So so FIPS is the tamper resistance specification that we're following, And so that's certainly something. So the device is incredibly hard to open. It actually has controls put into it where it can sense if you're trying to open it, and it'll wipe its memory when you do. So that's certainly a very important factor of creating a separate device. Yes?
Could I capture the Bluetooth traffic between your device and the laptop and replay that at a later time?
It is encrypted, first of all, but you could replay it. The thing is, each one of these signatures is only valid on the server side for about 10 seconds. So you have a time scenario there that you have to deal with as well. So it's somewhat possible, but then let's say you do capture the Bluetooth traffic from this token to this laptop. This laptop also sends additional metadata such as a MAC address and additional information over as well. So you kind of have to really, really try to do that. You'd have to have kind of root access to this device and be able to sniff this traffic in a 10-second increment and do everything.
So the server, though, wouldn't it send a different token every time you went to authenticate? So if you tried to replay it, it wouldn't be a sign of that token?
Precisely, yeah. And even the existing token is only valid for about 10 seconds. So you would have to block this token from getting there in the first place and then replay it in a 10-second and send all the metadata from the laptop and the browser along the way. So,
Impossible is that?
yeah, I'm not going to say it's impossible because I'm a security guy, but it's incredibly difficult. So I like to think that the likelihood is low. Yeah. So one of our initiatives at our company is with regards to the Internet of Things, right, which is something that everybody's talking about. So let's talk about, for example, a garage door opener that's an IoT node, or a door lock that's an IoT node. How do you authenticate to that, right? So let's say I want to authenticate to my door lock with my iPhone. I walk up to it and I have to maybe put in a PIN or something, and it's got Bluetooth and it communicates with it. It's a lot easier to use a biometric for that, right? Like just to use your thumbprint. But how do you make sure that that still works, even if your iPhone is jailbroken or rooted and it has malware on it, right? So some of the things that we're building is we're building this server-side key verification, signature verification system, and we're deploying it to IoT nodes. So like your door lock would do this challenge response system, and your garage door opener would do the challenge response system. And so that way you could securely authenticate to those IoT nodes with your biometric. And we think that's going to be really useful, and it's going to be something that's definitely going to be needed as the IoT grows and becomes more and more popular. I think the IoT market is going to be like $3 trillion by 2020, so it's going to happen. Thank you, guys.